Imagine a superhero particle that's responsible for making everything around us heavy. We'll introduce you to the Higgs Boson, also known as the God particle, and take you on a journey through the world of tiny particles and their incredible power to shape our universe. Imagine that the Higgs field is a magnetic field that is everywhere in the world. Now, this field has a special particle friend called the Higgs boson, named after a scientist named Peter Higgs. This pair does some pretty cool stuff. The Higgs field is like a sticky cosmic mud that sticks to particles and slows them down. What's more, mass is the word for this slowness. Now, the idea of the Higgs field wasn't just a guess, it was first thought of in the 1960s. But it took some time to find evidence. In 2012, smart scientists at the Large Hadron Collider, LHC, a huge machine for studying particles in Switzerland, found the Higgs boson. This was like putting together a puzzle and finding the last piece. The Higgs boson is a big deal in the world of particles. It weighs 130 times as much as a proton, which is a lot. Still, it's different from the other basic particles because it has no electric charge and doesn't spin. This makes it the odd one out. Let's talk now about bosons. These particles act as cosmic messages, making it easier for their particle friends to talk to each other. Think of them as the notes that are passed around the world. Electrons, for example, talk to each other using photons, which are a type of boson. But the story of how the Higgs boson came to be is what really gets our attention. It doesn't just appear out of nowhere, it comes from the Higgs field, which is like an unseen sea that covers the whole universe. When this field is shaken up, the Higgs boson is cooled. The real magic, though, is that the Higgs field isn't just for show, it's the cosmic glue that gives other particles their weight, making them either heavy or light. The mechanism that makes this happen is called the Brout-Englert-Higgs mechanism. The Higgs boson is a one-of-a-kind particle born when the Higgs field makes cosmic waves. This particle holds a crucial role in the grand scheme of particle physics, as it's the cosmic architect responsible for giving mass to other particles. This groundbreaking discovery completed the standard model of particle physics, essentially our handbook for deciphering the universe's tiniest constituents. Before this revelation, the world of particles held numerous enigmas, but now we have a satisfying answer to one of the most profound questions. Why do things have mass? Why is the Higgs boson called what it is? Jump into the quirky story behind this nickname and discover the profound science it conceals, from particles to the cosmos. Ever wondered how everything in the universe gains mass? So, why in the world is the Higgs boson often called the God particle? Well, it's a bit of a funny story that involves a Nobel Prize-winning physicist named Leon Lederman. You see, when scientists were trying super hard to find this elusive particle, Lederman got a bit frustrated. In his frustration, he jokingly called it the goddamn particle, because it was just so darn tough to detect. Now things start to get interesting. In the 1990s, Lederman chose to write a book about the Higgs boson. He wanted to call it the goddamn particle to show how tricky this particle was, but his producers didn't like that name, so they changed it to the God particle. And that's how the name became a nickname. But there was a catch. Calling it the God particle made people think about religion. However, don't let the nickname distract you from the real deal. The Higgs boson and the Higgs field are super important because they give all particles their mass. And when we say all particles, we mean everything, from stars to planets to us humans. So you could say that this nickname, while a bit over the top, reflects just how crucial the Higgs boson is in shaping the universe as we know it. Now, let's explore why the Higgs boson matters and why it's the key to understanding the universe's tiniest building blocks. Imagine a puzzle where all the pieces need to fit perfectly to make a beautiful picture. Well, in the world of tiny particles, there's a puzzle too. Scientists were trying to figure out this thing called the weak nuclear force, which is like the force that decides how atoms decay by changing protons into neutrons. Here's the complicated part. The carriers of this force, called the W and Z bosons, were supposed to have no mass at all. It's like saying they should be weightless. But if that were true, It would break a fundamental rule of nature: symmetry. Think of symmetry as a shape that looks the same even if you turn it or flip it. Nature likes things to be symmetrical. Adding to the puzzle, when scientists tried to put mass on these bosons, some of their predictions went a bit wild, like heading towards infinity. So there was a real mystery here. Then, in 1964, three clever physicists, Peter Higgs, François Englert, and Robert Brout, came up with a brilliant idea. They proposed the existence of a new field, the Higgs field, and found a way to make nature break its symmetry spontaneously. It's a bit like a pencil, standing perfectly straight on its tip, suddenly deciding to lean in one direction, destroying its symmetry. The Higgs field was like that pencil, and they suggested that when the universe was born, it was filled with this field in a balanced but wobbly state. So why is the Higgs boson so important? It's like the missing piece of the puzzle that helps explain why things in the subatomic world have mass, restoring order to the laws of nature and making the universe work the way it does. When the universe was just a baby, something remarkable happened. The Higgs field, a kind of cosmic field, transformed in the blink of an eye. This transformation, which happened super quickly, caused the field to lose its perfect symmetry. But here's the magic part. This loss of symmetry gave birth to what we call the Brout-Englert-Higgs mechanism. It's like the key to understanding why some particles have mass. Now, what's fascinating is that the Higgs field isn't picky. It doesn't just grant mass to the W and Z bosons, it's a mass-giving superstar for many other fundamental particles too. Without this field and its magical mechanism, all these particles would zoom around the universe at the speed of light, weightless and zippy. But here's the turn: not all particles get the same amount of mass. Those that cozied up more with the Higgs field, meaning they interact with it more strongly, end up being heavier. Even the Higgs boson itself gets its weight from its interaction with the Higgs field. Scientists confirm this by watching how Higgs bosons break apart or decay. Now, here's something cool. Not every particle relies on the Higgs field for mass. Take the photon, for instance, the basic unit of light. It doesn't need the Higgs field because it doesn't experience that symmetry-breaking trick like its boson buddies, the W and Z bosons. But wait, there's a catch. This mass-granting trick only applies to the super tiny fundamental particles, like electrons and quarks. Bigger particles, like protons, which are made up of quarks, get their mass from a different source. It's like the energy that holds their building blocks together. So scientists knew all this theory, but they needed proof. And finding evidence for the Higgs field required a colossal effort. It pushed the boundaries of what we could do with particle accelerators and detectors, ultimately leading to the creation of the Large Hadron Collider, LHC, the biggest and most advanced machine humanity has ever built. This was like the grand quest to unveil the secrets of the Higgs boson and its field. Can the Higgs boson's unique characteristics hold the key to unraveling dark matter and other universe mysteries? Let's discover. Finding the Higgs boson wasn't like stumbling upon it while taking a walk. These particles only existed in the crazy high-energy conditions of the early universe. So to spot them, scientists had to recreate those extreme conditions. They did this at the Large Hadron Collider, LHC, by making protons go super fast and smashing them together. When protons collide like that, it's like fireworks of tiny particles flying out. And guess what? Some of these particles were Higgs bosons. But here's the twist. Higgs bosons are shy. They vanish super quickly, so scientists couldn't see them directly. Instead, they looked at the particles that the Higgs boson turns into when it disappears. These particles showed signs of a boson with no spinning action and matched what theory predicted for the missing Higgs boson. Both the LHC Atlas detector and the Compact Muon Solenoid CMS detector were like superpowered cameras that captured these particle events. The big news came in at Geneva at CERN on July 4th, 2012, when scientists announced they had found the Higgs boson. But they had to do more tests and observations until March of the next year to confirm, yep, that's definitely the Higgs boson we've been hunting. Now, why is this so important? Well, it completed a big puzzle called the Standard Model of Particle Physics, which helps us understand the teeny tiny world of particles. But even though we've solved this part, there are still mysteries out there, like dark matter. And guess what? The Higgs boson, with its unique traits, might just help us unlock those mysteries someday. Finding the Higgs boson, which won the Nobel Prize in 2012, was just the beginning. With the LHC's high luminosity update, which is set to happen in 2029, scientists hope to open up new chapters and possibly find strange versions of the Higgs boson. Could these discoveries rewrite the laws of particle physics and redefine our understanding of the universe? Let's discover the answer. After the Higgs boson was finally discovered in 2012, two brilliant minds, Peter Higgs and Francois Englert, were honored with the 2013 Nobel Prize in Physics. They got this prize because of their groundbreaking Higgs field theory, which explains how particles get their mass. The Nobel Committee praised them for shedding light on the origin of subatomic particle mass and how it was confirmed by experiments at the Large Hadron Collider (LHC) in Geneva. But guess what? Finding the Higgs boson didn't mean the end of the story. Since 2012, scientists have been hard at work uncovering more secrets about this elusive particle. One major discovery was confirming how the Higgs boson breaks down or decays. And the adventure is far from over. The LHC is gearing up for its Run 3, and in 2029 it will be even more powerful after a high luminosity upgrade. This upgrade will let the LHC smash particles together even more often, creating lots of exciting opportunities for scientists to explore things beyond the standard model of particle physics. With this upgrade, the LHC is expected to churn out a whopping 15 million of these particles every year, compared to just 3 million in 2017. This could be crucial for detecting different flavors of the Higgs boson. Some theories in particle physics suggest there might be up to 5 different types of Higgs bosons, although they might not show up as often as the main Higgs boson. Even before the big upgrades, scientists have dropped hints about something intriguing, a magnetic Higgs boson. So the Higgs boson comes to surprise and challenge our understanding of the universe. The Higgs boson, also known as the God particle, is a remarkable and elusive particle that holds the key to understanding how particles gain mass in our universe. Its discovery at the Large Hadron Collider was a monumental achievement, completing the puzzle of the standard model of particle physics. Yet the story doesn't end there. With ongoing research and upgrades in particle accelerators, the Higgs boson continues to unveil new chapters in the quest to unravel the universe's deepest mysteries. How has the discovery of the Higgs boson led to further research and exploration in particle physics? And what mysteries of the universe might it help unravel in the future? Let us know in the comments below. If you enjoyed this video and want to see more like it, leave a like and subscribe to our channel if you haven't already. Tap the bell icon to turn on notifications to stay updated with all our latest videos. Thanks for watching, and I'll see you in our next video.